Okay, we just finished part 4, and now we're moving on to part 5. And part 5 is asking us, the part 5 of the final review is starting off with these equations to solve. And when you solve a quadratic equation, you want to be careful that you know what the restrictions are. That is, what answers can we not have, because we don't want the denominator to become 0. And in this case, if t was -1, -1 plus 1 would be 0, or if t was +1, 1 minus 1 would be 0. So our restrictions are, we know that t cannot equal 1 or -1. Now, it doesn't really matter if I get an answer of 4 and 7, then that doesn't matter. But if I got an answer of 1 or -1, I couldn't use it. Okay, what is the common denominator? Well, this right here is a difference of squares that factors to t plus 1 and t minus 1. So our LCD is t plus 1, t minus 1. And so we go back and we say, what was each of these terms missing? Well, the 7t is already over t plus 1, t minus 1. So it's not missing anything. This term is missing the t minus 1. So we're going to say 1 times t minus 1 over t plus 1 and t minus 1. If I put a term in the denominator, I had to put that same term in the numerator. All right, and then we have equals, and we have this next term. We had t minus 1, so we need to include the t plus 1, so we have to multiply the t plus 1 up here. Okay. Once you get your denominators to be the same, you can just get rid of them. You don't need them anymore. You could just totally get rid of them. But what we're actually going to do right now is we're going to multiply this whole problem by the denominator, which is t plus 1, t minus 1. And you can see what happens. T plus 1 times t minus 1 cancel here, it cancels here, it cancels here, and our denominators are just gone. So I have 7t plus t minus 1. Now remember, I'm kind of putting hooks on my t's because they look a lot like pluses, but remember to think about your signs. That t minus 1 equals, and over here I have t plus 1. So I have 7t plus t is 8t. And if I add 1 to both sides and subtract t from both sides, I get 7t equals 2. And if I divide both sides by 7, I get t equals 2/7. Now, I don't have to worry about these restrictions because I didn't get that for an answer. I'm just done. That's all I have to really worry about. So in this case, what I did, because there's kind of a couple different ways to do it, so I'm going to do this one slightly differently. But what I did was I rewrote everything that with the LCD under it, and then I just could cancel those right out, and I left with this equation with no fractions to worry about. There's another way to think about it. This one, as it turns out, is going to factor to be x minus 3 and x minus 6, which is very convenient because that's what we have over here. So this is our LCD, x minus 3 and x minus 6. So what are their restrictions? Well, x cannot be 3 or 6. 3 minus 3 would be 0, 6 minus 6 would be 0, so it can't be either of those. Now the way I'm going to think about this is I'm going to multiply each term by the LCD. So I'm going to say x minus 3, x minus 6 times x over x minus 3. I'm going to say 9 over x minus 6 times x minus 6, x minus 3. And then over here, I'm going to have negative 16x plus 99. And I'm just going to write LCD because I'm running out of space, which has that whole LCD, and I'm going to multiply it times that LCD, which means that's just going to go away, right? But on the left side, the x minus 3 is going to cancel, and I've got an x and x minus 6. Here, I've still got the negative 9, but the x minus 6 cancels, and I've got x minus 3 left. And over here, I have negative 16x plus 99. Okay, now I have to distribute on the left side and bring everything over and blah, blah, blah. So I have x squared minus 6x minus 9x plus 27, because negative 9 times negative 3. And then I'm going to go ahead and swing this over. This is going to be positive 16x when it comes over. I'm going to add it to both sides. And negative 99, because I'm going to subtract that from both sides, equals 0. I'm going to set the whole thing equal to 0 in case I need to factor it. Well, I have one term that's x squared, and I have negative 6x, negative 9x, and positive 16x. So I have negative 15 and positive 16, so I have 1x. And then I have negative 99 and a positive 27. So I have more negatives, and I have to just say, what is the difference between 99 and 27? And that's 72. So I have negative 72 equals 0. To solve this, we're going to factor, and I can see that that's going to be x times x, and 9 times 8, and I want more positives because I have a positive x, so positive 9 and negative 8. Set each of those equal to 0. To find your two answers, you would expect two answers because we had something to the second power there, and x is either negative 9 or x is positive 8. And that is not one of our restrictions, so we're fine. All right, so those are how you solve those kind of more difficult equations. Kind of different way. This one I just made all the denominators the same and then went back and just got rid of those. This one I just multiplied everything by the LCD and they canceled out. Either way, you want to get to a point where you don't have any denominator left as you're working that problem. Okay. On your final, you're going to have a question that has to do with variation. It could be inverse variation, and we have inverse variation, the formula. You should have both of these in your notes. Inverse variation is y equals k over x, and direct variation is y equals kx. So you're going to kind of solve the problem the same, except you have to use the correct formula. So this says p varies inversely with q. So instead of this, what we have is p equals k over q. P is varying inversely with q, so we have the k still, which is our constant, but instead of x and y, we have p and q. And then it says p is 10 when q is 6. And so the first thing you want to do is say, well, what is k then? So we find out that by multiplying both sides by 6, and we get k equals 60. Find p when q is 15. Now we know that k is 60, and we're given that q is 15. All we have to do is take 60 and divide by 15, which is 4, and that's the answer to that. Now, if it had said direct variation, we would do the same thing, but we would start off saying, okay, p is directly related to q. So it would look something like this, and then we would have to plug into that formula, but we would first find the k, and then we would find the second variable, just using one of those two formulas, depending on if it says inverse or direct when you do the problem. All right, that's it. Have a fantastic day, and we'll see you next time.